All right, let's start the lecture. So the next paragraph is additions of sequences. So if we write that z of n is equal to x of n plus y of n, this means that z of n is equal to x of n plus y of n for all n, or for each, let's say for every n. I'm going to write for every n to make it more emphatic, for every n. So example. So suppose you take, I like to take the same sequences every time. -2, -1, 0, 1. Four, 3, 2, 1. So I call this x of n, and let's say plot z of n equals x of n minus x of n minus 1. So that is not very difficult. So you plot x of n minus 1. So you're going to get shifted. You see, I cannot do that on the board, on the blackboard. So this is x of n minus 1. And how do you plot z of n? So you prepare your plot. And you work step by step, right? For each n you write, so you prepare 1, 2, 3. So at 0, z of 0 is is this minus this, right? So you get what? At 0, what do you get? At 0, what do you get here? -1. At what about at 1? The same thing? What about at 2? Again? What about at 3? Okay, now what about at -1? Again? What about at -2? what about at minus 3? Okay, so not difficult, right? You just need to, yes?
Why do you have the same at 4?
At 4? Okay, you see when I stop plotting, it just means it keeps on going to plus infinity, right? I stop, but the sequence goes all the way to plus infinity, and when I stop plotting, it means that it's all zeros. All right, in my plots, because I have to stop plotting, right? Right. So I imply that it's full of zeros. All right, so now I'm going to teach something similar, which is multiplications of sequences. So you know what? I'm going to copy and paste because it's almost the same thing, except that I'm going to change addition by multiplication. Multiplication. Oops. So here we are going to have multiplications of sequences. So same thing, except that you are going to have multiplication. So do you want an example? Let's see what kind of example. Take x of n like that. And it's a plot z of n equals x of n times x of n minus 2, for example. So, oops. What is x of n minus 2? It is this shifted by 2 to the right. So you get this. So this is x of n minus 2. Can you tell me what is going to be z of n? So what will it? That's correct. It's just going to be like that. So this is z of n. Everybody agrees? Now you also have multiplication of sequence. Or actually, I'm going to call this instead the scaling of a sequence. Scaling of a sequence. So if you see this, y of n equals alpha times x of n, then this means that y of n equals alpha x of n for every n. Okay, no difficulty, right? Okay, now there's something I forgot to teach last time, is a constant sequence. So that is best located in the previous lecture, constant sequence. Suppose I write x of n equals c. Normally this wouldn't be accepted because x of n is a sequence and c is a number. A sequence, remember, it's not a number. It's an infinite number. It's a sequence of an infinite number of numbers. So if I write a sequence equals a number, normally it doesn't have a meaning. However, if we do write it, it will mean something. This means x of n equals c for every n. You get this? You cannot say a sequence is equal to a constant, but if you write it, it will mean that the sequence is constant, equal to c. All right, so you have this. Yeah, it's a fast way to plot a constant. It goes really fast like that, huh? Exponentially. So x of n will be equal to c infinitely. All right? Keep that in mind. A sequence cannot be a number unless it's constant. Okay, so now we are going to do the second difficult exercise of this course. And what is it? I'm going to take any sequence x of n, any, right? And I multiply it with delta of n. The impulse sequence. So this is the multiplication of two sequences, and you know what that means. The question is, I would like you to give me the description of a sequence, no, actually the name of a sequence that gives the same result but has a different formula. Give me a sequence that gives the same result but different formula. You saw that lecture before.
No, I
Did you hear what he said? Oh, too bad. Did you hear what he said? No, good. he gave the correct answer. So I will let the others try to get it. You didn't hear what he said, right? Okay, so let's do some. So again, I don't want you to remember a formula by heart. I want you to figure out the formula by logic, right? So we are going to, so just consider a random sequence, x of n. Okay? Whatever. X of n. You want to multiply this by delta of n. So we have 1 here, right? Okay? So now let's plot the multiplication between the two. So what do you get? You get 0 everywhere except at 0. But at 0 you don't get 0. What do you get? Yes, you get 1 times this guy. But this guy is what? It's x of 0. Did you say x of n? But you didn't tell me what is n. So it's x of 0. All right, so now you answer this question. Can you give me a formula which is different but gives the same result? Delta of n times x of 0. You agree? All right. So some of you may not find that easy, but on the left side we have multiplication of 2 sequences together. On the right side we have something different, which is the scaling of delta of n with a number. X of 0 is a number. Could be 2.1, pi, square root of 2. It's a number, all right? So this is a scaling of a question with a number, and this is the multiplication of 2 sequences. However, they give the same result. The only way to see it is to see the picture. It's the picture that tells you this. No, there's no memorization by heart. You don't want to remember this by heart. You want to see it, and when you see it, then you know it. You see? Just parenthesis, talking about the brain. You know, I saw in a TV documentary that there are 2 areas in the brain, one in front and one in the back. So I forgot which one is which one. But one is memory. Maybe the memory is here. And another one is reasoning, is in the back, right? So where you store your telephone number is here. And where you store reasoning is in the back. But the scientists, they say that memory is consolidated by interaction with the back. It's like reasoning helps reinforcing memory. when you have like interaction between the front and back, you reinforce the memory, right? So eventually you may remember this by heart, but what helps a lot is when you think about it. When you think about it, then eventually it becomes part of your memory. You no longer need to think about it, but it's very important to do this training between the front and the back. So I'm saying this because if you just you limit yourself to just looking at the formulas and memorizing by heart, then you're just using the front, but that is weak. All right, so now we're going to see if you really understand this. Okay? Question?
When you say that that equals to x of 0, since you know that delta of n will be 1.
So you say we write this equals x of 0. That's what you say, right? Do you see the pointer? Do you see your mistake? If you say that this is a sequence, if you say it's equal to this, you say it's constant equal to x of 0. Your mistake is to think that x of 0 is the description of something is sorry, let me say it again. You think x of 0 is the description of a sequence that is x of 0 at 0 and 0 outside. That's not true. X of 0 is a number. X of 0 points to the value of a number. X of 0 is 2.1. So if x of 0 is 2.1, then you write this is 2.1. And when you write this, you say, oh yeah, it's wrong. Okay? All right, so now I'm going to test you. If you really understood this, you should be able to answer the next question. I wanted, can you see now? Next time I will move. Say it again. You know, I'm going to collect all these answers. You are allowed to.
X of n naught times delta n minus n naught.
No, too late. You can add a new answer.
Okay. X of n minus n naught times delta of n.
Oh yeah, and somebody said that x of n minus n naught. Lots of choice, isn't that fun? Yeah, more? Isn't that amazing? The multiplicity of answers, and you know that there's only one that is correct. So we vote, right? Oh, no, or more?
Another, yeah. Delta of n minus n naught, no, x of n minus n naught times delta of n minus n naught.
All right. So you know what this is telling? You know there's only one answer that is correct. This is telling that many of you just work on guessing, and this is not correct. This is not right the way.
There will be no x of n minus n.
It's here. It's here already.
No, times delta of n minus n naught.
Yeah. No, but this is a sequence because you have n in it. All right. So let's vote. How many of you vote for the first one? The second one. The next one. Okay, majority. The next one. Right. The next one. The next one. The next one. You don't vote. You don't vote for yourself. Oh. Look, what did we say about this one? What did we say about this one? It's a constant. If you say it's a constant, do you think the result will be a constant? No. You can tell it's already wrong. It's already wrong, right? So, you know what? I'm going to just redo the picture. Except that I'm going to change the I'm going to say that I want to plot this shift to delta. So what does it look like? What does it? It's like that, but it's located at n naught. Do you agree? It will be located at n naught. Okay. So that means, of course, you need to plot the two sequences synchronized. All right, synchronized. So you're going to get n naught here, and then n naught plus 1, n naught minus 1 here, all right? So what is going to be this sequence? It's the same thing. It's going to be 0 everywhere except at n naught. But at n naught is going to be what? It's going to be 1 times this guy. What is this guy? So it's going to be x of n naught. So this sequence is also this sequence multiplied by x of n naught. This one. Yeah, yes, you won. Good.
Professor,
Yes.
how would you plot the very last option that we proposed?
Okay. So if I plot it, I would get this. Who asked the question? Yeah. No, it's not clear.
No, I'm talking about the very last option.
This one?
Yeah.
This one would give you this one. Yeah, you see that? Okay, so let me get back to the correct answer for this one. All right, so I erase this. All right, so I want you to, for those of you who didn't get the right answer right away, I want you to think about the mistake you made. You see, it's not, you know when you are going to do the homework and then get back the solution? I don't want you to just say, oh, my answer was wrong, that was the correct answer. No, that's not the right way. The right way is to say, why did you think this way? What was wrong in what you thought? It's this realization that is going to make you make a progress. You see, it's the, in a way, I mentioned to you last time, I will not worry if you don't return the homework. On the other hand, what is important is that you spend time thinking about the homework, trying to find the solution. And not finding the correct answer right away is okay. What is very important is to realize why your answer was wrong, what was missing in your thinking. It should point you that, oh, there's something in the lecture that you didn't get right. So you have to get back to this lecture and say, what was wrong that made not find the correct answer, and then you look at the solution and then you try to understand why you were supposed to get the correct answer. You have to understand, it's not just that, oh, that's the correct answer, oh yeah, sorry, I didn't get it. No, you have to see why you were expected to see that correct answer. That means you were expected to understand something from the lecture that you missed. This is the type of exercise you have to do to do well, all right? So it is okay if you have really a hard time finding the answer. I sometimes, some of you send me emails before the homework is due, like asking things, and often I say, I don't give the answer. I just give maybe just pointers, because the whole point is to think about it, not necessarily to get the right answer automatically. Okay, so. Okay, I'm ready to go to the second paragraph. Discrete time systems. So a system is a black box that has an input sequence and an output sequence. It's a transformation, okay? So a black box that transforms a sequence into another sequence. So it looks like a simple definition, but you're going to have a hard time on this. It's similar to when you write y equals f of x. It's a transformation, right? It's a transformation. So when I say y equals f of x, am I giving you x? No. I'm just saying how x becomes y. I'm not giving you a number x. I give you a way to transform x into y. You could call x the input. You could call y the output. But similarly, we have y of n equals s of x of n. Input, output. But what is the difference between this and that? In this case, the input is one number, and the output is one number. Here, the input is how many numbers? Infinite number of numbers. It's something crazy. And the output is an infinite number of numbers. And this is where you're going to have a hard time. We transform an infinite number of numbers into another infinite number of numbers. Okay? We could say also similar to you remember what is a matrix multiplication? If I write y1, y2, yn equals matrix times x1, x2, xn. You understand? You know that how this works. It's a whole, it's an input, output. How many numbers do you have in the input? N numbers, which are transformed into n numbers. This transformation is complicated. For example, suppose I modify x1 here. Can we say that only y1 will be modified? No. The modification of just x1 may imply the modification of all of the output values. In fact, and vice versa. Each of the output value may depend on all of the input values. So you get that complication, right? Just say this is the same thing as this, but n is plus infinity. In fact, it's even worse because you see this is like the time index. You can think of a subscript as a time index. Here you have infinite indices, but you also have negative ones. It's even worse. And it's even worse than worse because here this is what we call a linear transformation. But here we don't have it's not a system is not necessarily linear. Even though this class is called linear systems, but in general a system may not be linear. All right. Now, the output has another name. It's also called the response. All right? So we say that y of n is there's some type of alert. What wind or what? Snow? No, there's no snow. Yes? All right, so we say y of n is the response of S to x of n. Okay, we also saying that x of n is the input and y of n is the output is equivalent to saying that y of n is the response of S to the input. all right? The response of the system to something. Okay? Example, we are going to try an example. Example. Let S be the system such that for any input x of n, S of x of n, so the output, S of x of n is the output, equals x of n squared minus 1. This system is well defined because for any input you will know the output. Y of n is x of n squared minus 1. Okay? So plot the response of S to x of n, or, you know, I always like to recycle my examples. All right, so we you input this into the system, and you know that the output y of n is going to be x of n squared minus 1. So plot this. All right, so x of n squared minus 1 is not a time shift, it's some type reversal, it's something we didn't see. So the only way to do it is to work time index by time index. To plot this, so at 0 you want to plot y of 0. Y of 0 is what? Is x of minus 1. All right? So at 0 you're going to get x of minus 1. Y of 1 is what? X of 0. Y of 2 is what? So is 0. At 3 is going to be, I mean, all the way is going to be 0, all the way to plus infinity. All right? Because y of 4 is x of, no, y of 3 is x of 8, etc. Right? It grows. What about minus 1? It's x of 0. How much is x of 0? At minus 2 is 0. That's it. All right? All right. So now we're going to do some exercise. A mistake. I teach mistakes. Is it good? Okay. Did you know that in my class, every good news has a catch? So I say, I teach mistake. This is good news. What's the catch? Yes. So if I declare a mistake in class and you make that mistake, you get shot. That's the bad news. But if I don't teach mistake, if you make the mistake, you don't get shot. So what do you prefer? I don't teach mistake. All right, mistake. Mistake. So here we have x of, it's a mistake I see often, right? S of x of n is y of n. And y of n is y of n. So S of x of n minus 1 is y of n minus 1. All right, so I need to explain. The typical reasoning, I mean, typical wrong reasoning. Is to say that this implies S of x of p equals y of p. Take p equals n minus 1. Therefore, S of x n minus 1 equals y of n minus 1. Okay, what was wrong in this reasoning? Okay, so point exactly what statement is wrong.
N is equal to x p is what the things that are close to p are and those that are close to each other.
So this statement is wrong.
Yes.
That's correct. S is, it's not because it's a transformation. It's because it's a transformation from one sequence to another sequence. When you write this, you transform one number into a number at the same instant. But that's not true because remember, if you write this, that, for example, think of the matrix transformation. All right? So if you write that x of p becomes y of p, it's like saying x of 1 becomes y of 1. X of 1 becomes y of 1. But you cannot write this because it doesn't make sense. The transformation only makes sense when you use the whole sequence. The whole sequence that becomes the whole sequence. So if you only know one number, you don't know what is going to be the output. And the other thing is that suppose you all know all of the input values, and you modify. Suppose you only modify x of p in this matrix, in this vector. Are you going to have that y sub p is the only value that it gets modified? No, that's not true. That's right. That's right. So writing this is already wrong. Writing this is already wrong. You cannot say, oh, for this particular value of n, I will get this particular value of n. Okay. So since this is wrong, then this becomes wrong. I mean, okay. This already wrong. Doesn't make sense. Okay. But just for the sake of the exercise, just for the case of the exercise, with previous example, let's plot S of x of n minus 1 and y of n minus 1. Let's plot these two guys, just for the sake of it. All right? So I'm going to call all right, so I'm going to copy and paste no, it's not the end of the class. All right, so let's plot that. So what I'm going to plot here, I'm going to plot I want to plot this, okay? I'm going to call it x prime of n. All right, so this is shifted by 1 to the right. So what will you get as output? Y prime equals x prime over n squared, right? So can we do that fast? So this is y prime is s of x prime n and it is equal to this. Okay? So can we do that again? That's it, we can go fast now, okay? Y prime of 0 is x prime of minus 1, which is 4, right? So we're going to get four. Y prime of 1 is x prime of 0. They should take it easy. I mean, nothing bad will happen here. At minus 1, at 2, it's still 0 at 2, because it's x prime of 3, still 0. All right, so this is what you get, okay? Y prime of n is like that. Meanwhile, what is y of n minus 1? All right, so this is s. This is x of s of x of n minus 1, right? You agree? This is x of n minus 1, and this is s of x of n minus 1, right? So we found this one. We have this one, right? We just need to plot this, and we're going to see if they are equal. So, but we know what is this because we know y of n. Y of n is like that. Y of n is like that. So what is y of n minus 1? You shift this by 1 to the right. This is y of n minus 1. Right? So are they equal? This is this, and this is that. Are they equal? No. No. Okay, let's recapitulate. All right, so what we had is that so what we did here, we had this as the initial input-output pair. What did we do here? We shifted this to the right by 1, right? And then the wrong formula claims that if you shift this by 1 to the right, then the output is the same shifted by 1 to the right. Okay? So the wrong formula says that if I shift this to the right, I should obtain this. But it's wrong, because actually you obtain that. All right? So this tells you that this reasoning is, this does not imply this. And the reason is that it emphasize that reasoning that is wrong. You cannot just say that x of p becomes y of p. It's not right. It's very complicated. You need to have the whole sequence first, and then you can see how it gets transformed. You cannot say this guy becomes this guy becomes this guy. It's not true. All right. All right. I'm going to teach a certain notion that you never heard before. Something You never heard before that is called okay, let's say this. What?
What if you have this information? Will we be able to take access to the wireless?
If you what?
If we have to have this information.
If you, sorry, say it
If
again.
we have this information to access, will we be able to get access to the wireless?
I don't understand your question. Sorry, I don't understand. I don't understand your question. We have a transformation from a whole sequence to a whole sequence. I cannot answer because I have defined Y of n to be transformed through S. That's my definition of Y. All right, I'm going to teach you something you never heard before. It's something called impulse response. The impulse response of system S is the response of S to the impulse sequence. Did you understand the definitions? Did you understand? No. Remember what that means? Okay, you didn't understand because the impulse frequency is delta of n. You understand it better? What does it mean to say the response of a system to an input? It means the output. So, in other words, it is the output of S when the input is delta of n. Do you understand that better? If not, in other words, it is the sequence which is the transformation of delta of n by S. Do you understand this? If not, in other words, it is what you get here. You understand this? If not, okay, I stop. You know why I insist? You'll be amazed that I will ask you this question in 2 weeks and you will have forgotten it already. I will say, what's the impulse response? He will say, h of n. What is h of n? Oh, it's the impulse response. I insist because I insist on the concept. Do you agree with me that you never studied this before? Yes? Right? You never studied what the impulse response, because when you look at the definition, you never heard that before, right? But don't you think that it just explains what it is? The meaning of impulse response is impulse response. Ah, now everything is clear suddenly, right? Right? Something you never understood. They just didn't tell you impulse response means impulse response. What they explain to you, I know what they explain to you. They say impulse response is h of t, right? Ah, yeah, h of t. Ah, yeah, I know that. But again, I have this message that I don't care about notation or letters. I care about the meaning, concept. Example? You want an example? All right. Plot the impulse response. Plot the impulse response of the system S defined by S of x of n equals f of x of n squared minus 1. Sorry, I like to recycle examples. All right, so what do? You input delta of n, you do this. You do this. You get what is here. All right? So what is here is going to be delta of n squared minus 1. Right? Impulse response. In this example. But we ask plot. But we know how to do it, right? You know that delta of n is like that. Can you plot this? Can you plot this? I'm sorry, I point with my finger on my tablet, but I expect that you see my finger there. No, you won't see it? Oh, okay, so sorry. Technology is not advanced enough. All right, so we do the same thing as before. What is this at 0? This at 0 is delta of minus 1, which is 0. At 1, this is delta of 0, which is 1. And then 0, 0, 0. At minus 1, at minus 1 is delta of 0. You know, this sequence is going to be even because when you put a minus sign to n, it gets cancelled. Plus minus n give the same result. So you're going to get always an even sequence. All right, so the impulse response is this. Sequence. All right? All right, so I'm going to ask a stupid question. Suppose we know the impulse response of S. And the question is, do we know S? Of course not. Because we know S only if we know the response of S to any input. It's like if I say f of 1 is 2, do you know f? No. You know almost nothing. Same thing. If you have a system, you only know one input, you know nothing about that system, right? So you agree this is a stupid question. You don't dare to say it, but it's, yes, it is. Of course not, all right? So I forgot to mention a remark. We say that two systems S and S prime are equal when the response of these two systems are the same for any input. For any input x of n. All right. Okay, I guess I don't have time to continue. So starting from next time, we are going to specialize in certain systems that have nice properties. Until now, a system like that is boring because it doesn't have any property. But we'll, you know that the course is called linear systems. I will tell you that this is a wrong title, but linear systems will be a big part of it. All right. Okay, so